It was a crisp autumn morning in 2009 when NASA scientists, staring at the screen in front of them, received a message that would forever change the course of space exploration. In an era where humanity had already ventured to the moon and beyond, this discovery seemed almost impossible. But there it was, a confirmation that the moon held a secret, one that had been hidden in the shadows for billions of years. Water. In the craters of the moon. For generations, scientists had speculated that there might be some form of water on our lunar neighbor, but the evidence had always been elusive, locked away in the moon's cold, dark craters. Water was the holy grail, the key to unlocking sustainable space travel, to making the dream of a permanent human presence in space a reality. Water on the moon wasn't just a scientific curiosity, it was a lifeline. If it could be found and harnessed, astronauts could use it for drinking, growing food, and even turning it into rocket fuel. The very essence of future space missions depended on it. The story of this groundbreaking discovery began years before that fateful autumn morning. It began in the laboratories, the meeting rooms, and the minds of brilliant individuals who refused to give up on the dream of a new frontier. Among them was Dr. Sarah McAllister, a geochemist whose life was driven by the pursuit of understanding planetary science. From a young age, Sarah was captivated by the idea of exploration, drawn to the stars and the mysteries that lay beyond the Earth. She had spent her early career studying Earth's water resources, but it was always the moon that fascinated her. Her team, based at NASA's Goddard Space Flight Center, was tasked with studying the moon's surface, investigating the possibility that water might be present in permanently shadowed craters near the lunar poles. These areas never saw sunlight and were frigid enough to harbor water ice, a possibility that had been speculated for decades but never confirmed. However, there were many obstacles. The first, and perhaps most challenging, was simply getting the right instruments into space. For years, scientists had been designing and testing new ways to measure the moon's surface from afar. But as always, there were setbacks. Budget cuts, technical failures, and political roadblocks made the mission seem impossible at times. But Sarah's determination was unwavering. I knew that if we could just get a clear signal, just one definitive piece of evidence that water existed on the moon, everything would change. It wasn't about just proving a theory anymore. It was about changing the future of humanity, Sarah once said in an interview. In 2009, the opportunity finally arrived. NASA launched the Lunar Crater Observation and Sensing Satellite, LCROSS, a spacecraft designed to crash into the moon's south pole. The mission was bold, risky, and, at the time, considered by some as nothing more than a Hail Mary attempt to find the impossible. It was essentially a cosmic game of chance, but one that had the potential to yield unprecedented results. The spacecraft would smash into the moon's surface and send a plume of debris into space, where telescopes on Earth and in orbit could analyze the composition of the material that was ejected. The team was hopeful but realistic. They knew that the moon was not a hospitable place. It was hostile, a cold and barren world. But the prize was too great. The night of the crash was tense. Thousands of miles away from the lunar surface, Sarah and her colleagues huddled around monitors in the NASA control room, their faces illuminated by the soft glow of the screens. Every eye was fixed on the spacecraft as it neared its target. The countdown to impact was agonizingly slow. It wasn't just about the science anymore, it was about the culmination of years of hard work, research, and sacrifice. The fate of the mission rested on a single violent moment. Then, at 7:31 p.m. Eastern Daylight Time, LCROSS impacted the moon. The moment the spacecraft hit the lunar surface, the shockwaves sent a plume of dust and debris into the lunar sky, which was captured by telescopes waiting on Earth and in orbit. Seconds felt like hours as scientists frantically processed the data. They were searching for one thing, a clear signature of water in any form. The analysis took days, but the moment the first signs of water appeared on the screen, Sarah and her team could hardly contain their excitement. It wasn't just a trace. It was more significant than that. The data confirmed the presence of water ice in the permanently shadowed craters of the moon. The discovery was a breakthrough, the first definitive evidence of water on the moon. It was like finding a needle in a haystack, except this needle was one of the most precious resources humanity could ever hope to find. The implications were enormous. Water on the moon meant that human exploration of space was now a step closer to becoming sustainable. Astronauts could potentially live and work on the moon for extended periods, using water for hydration, food production, and even the creation of oxygen and fuel. The dream of a lunar base, a stepping stone for further missions to Mars and beyond, suddenly felt possible. For Sarah, the moment of discovery was both overwhelming and humbling. I'd spent so many years dreaming of this moment, and to actually see the data, to know that we had found water, it was like every sacrifice, every late night, every moment of doubt had led to this, she recalled, her voice thick with emotion. It was beyond anything I could have imagined. But the journey wasn't over. In the years that followed, the scientific community continued to study the data, confirming that water wasn't just a rare occurrence, it was widespread across the lunar surface. This discovery ignited a new era of lunar exploration. Agencies like NASA, along with private companies, began ramping up their efforts to return to the moon, this time with a clear focus on establishing a long-term human presence. The discovery also had a ripple effect on space policy. For the first time in decades, nations began discussing a shared vision for the moon, one that transcended individual political agendas. The concept of lunar bases became a reality, and the idea of using the moon as a platform for future missions to Mars and beyond gained traction. Water on the moon had not only altered the landscape of scientific exploration but had united the global community in ways that had never been seen before. Despite the triumphs, the journey wasn't without challenges. The technology needed to harvest and utilize the water found on the moon was still in its infancy. There were questions about how to extract the ice and turn it into usable water, oxygen, and hydrogen, critical components for fuel. But where there was once uncertainty, there was now hope. New teams of engineers and scientists were formed to tackle these challenges, and their efforts have continued to build upon the foundation laid by Sarah and her colleagues. For Sarah, the discovery marked the culmination of a lifelong dream. But it also signified the beginning of something even greater. She watched as new generations of scientists and engineers set their sights on the moon and Mars, inspired by the discovery that had forever changed the way humanity viewed space. She knew that the work she and her team had done was just the beginning. In the coming decades, people would walk on the moon again, and the water they had found would play a key role in their survival. And so, the moon, once seen as a barren and desolate place, was transformed in the public imagination. No longer a dusty relic in the sky, the moon was now seen as a potential home, a place where humanity could thrive and take its next steps into the cosmos. Looking up at the moon now, as she has done so many times before, Sarah feels a sense of fulfillment and wonder. The dream of a new frontier is no longer a distant fantasy. It's real. And it all started with the discovery of water. A discovery that proved that even the most impossible dreams could come true. The discovery of water on the moon didn't just open doors for science, it opened doors for humanity. It was a reminder that the pursuit of knowledge is not just about what we can achieve on Earth, but about reaching for the stars, even when the odds seem insurmountable. The water on the moon is not just a scientific discovery, it's a symbol of our potential, a reminder that no matter how far we go, there's always more to explore, more to discover, and more to dream. That fateful day when Sarah and her team saw the first signs of water on the moon marked the beginning of a new chapter in human history. It wasn't just a victory for science, it was a victory for all of humanity, proving that even in the coldest, darkest corners of space, there's always hope, always a chance for discovery. The future of space travel, and perhaps the future of humanity itself, had been rewritten that day, a day that will live on in history, forever etched in the annals of exploration. And for Sarah, who dedicated her life to this pursuit, it was a moment of fulfillment, knowing that she had played a role in changing the future for generations to come.